So we are recording, and here we are. All right, so that was our community meeting question. All right, so again, we're still going over these circles. So by this point, you all should have that goal under control. If asked to write or discuss the definition of a diameter, a radius, or a chord, you should be able to have some discussion on it, how they relate to each other, and how they differ from each other. Okay. And in our study of diameters, the radius, and chords, we are also going to talk about what's going on inside of a circle. So we're going to talk about inscribed angles. We're going to talk about central angles. And starting next week, we are going to talk about circumscribed angles. That's angles outside of the circle. So our agenda for today, we just had our community meeting question. We're going to do a quick review of the angles inside, and that is just a slide. The slide that we created last class, we just going to look over that. We are going to talk about arcs of a circle. So again, I hope you remember some of these concepts from last term. We're going to do a little bit of practice that relates the measures of arcs and angles, and then we're going to close. Okay, so I hope that we, get to it, or we will get into as much of it as we get to. All right, so we talked about angles inside of our circle. And again, remember, this is circle P because the letter P is the letter at the center of the circle. So whatever letters at the center of the circle also names the circle. So somebody pointed out angle FCE. Started at F. C is the vertex. Ended at E. So it is an inscribed angle because the vertex is on the edge of the circle. The vertex is C. So remember, when you name an angle, the letter in the middle is the vertex. Okay? And an inscribed angle is made up of two chords. Okay? So one of the chords that makes up this particular angle also happens to be a diameter of the circle. Okay? And then 3 other angles were pointed out. Angle A, P, B, angle E, P, D, and angle A, P, C. That all 3 of them are central angles because, again, the vertex P is at the center of the circle. And a central angle is made up of 2 radii. Okay? So remember, So we know that radii is just the plural of radius. So this central angle is made up of the radius from P to A and the radius from P to B. Okay, and they meet here. So everybody cool on that? So you can see the difference between a central angle, vertex at the center, versus an inscribed angle, vertex on the edge of the circle. Okay? All right. So now let's talk about what's going on around the edge of the circle. So when we talk, now we are going to fill this slide. We are going to fill this slide in as we talk about it. So what I did in this version, again, I stayed with the same picture. I stayed with the same picture. So, but what I did was I extended the I extended some of the line segments so that they would go outside of the circle. So again, when we talk about arcs, remember an arc is just a piece of, it's the edge of the circle between 2 points. So we are going to fill this slide out as we go. So got a question. Does anybody remember how to describe any of these types of arcs? We talked about it last term. All right, so can you describe a minor arc, a semicircle, or a major arc? What do you know about them? I'm going to show you the picture again. So again, can you describe a minor arc, a semicircle, or a major arc?
A semicircle would be half, right?
Yep. Okay. Yep. So let me move this up. Yes, a semicircle would be half. Exactly. All right. So if a semicircle is half, what is the measure of a semicircle?
180.
Exactly. Okay, so a semicircle, MEASUR, measure equals 180 degrees. All right, so if that be the case, can you relate a minor arc or a major arc? Can you also relate that to 180? So a semicircle we're gonna put an example in here. All right. So if a semicircle measures 180 degrees, how would you name it if we are talking about arcs? Remember, tell me where it starts. Well, no, I'm gonna just leave it there. Can you name one? If you can't, that's okay, because we're gonna get there. Can you tell me give me a description of a minor arc or a major arc? And again, if you can, I would like you to relate it to 180 degrees. I want 180 degrees to be in your definition. Did that make sense? Look at your old notes.
Would the major arc be 360?
No, because remember, an arc is a piece of it. is a piece of the 360. Okay, so, all right, so wait, so let's step back. Yeah, so we established the whole circle is 360. Yep, I'm there. All right, so now, if I said to you, a minor arc, the measure of a minor arc plus the measure of a major arc equals 360, right? Because that'll be the whole circle if I have a minor arc and a major arc. We just discussed that a semicircle measures 180 degrees. So I'm asking you, how do you think the measure of a minor arc relates to 180 degrees? You know relationships in math. Less than, greater than, less than or equal to, greater than or equal to, not equal to, and equal to. So what do you think about the measure of a minor arc as it relates to 180 degrees? It says it's minor.
Equal to.
Say it again.
Equal to.
No, equal is a semicircle. We got the equal
but,
right here.
All right, so, but you just said the minor arc and the major arc. I don't know. Hold up. Can you explain that a little bit more?
Yep. I said a minor arc plus a major arc is the whole circle. So wait a minute. Let me stop sharing for a minute, and I'm going to show you what I'm talking about. I'm going to stop sharing because I'm going to show you. Hey, Ash. I'm going to show you what I'm talking about. All right, so.
Hey.
What's going on, girl? I'm glad you're here, boo. All right, so if this is our circle, you all can see my board, right? Boy. You all can see this?
Yeah.
Okay.
Yeah, we can see.
Okay. All right, so this is your circle. So this is the center of the circle. I know my circle beat up. So I'm saying to you that, so we know that the whole circle is equal to 360 degrees, right? I said a minor arc plus a major arc is equal to 360 degrees. So when you have an angle, let's say, hello, good morning, glad you're here. So let's say we have an angle, we have a central angle, let's say. All right, so we have this angle here. Boop, boop. All right, so let's call this A. We're going to call this C. And this is B, right? So every angle, and we're going to now extend this a little bit. Every angle breaks a circle into a minor arc and a major arc. So you have the smaller piece, and then you have the larger piece. So the minor arc is going to be less than 180 degrees. And then the major arc and that's all of this piece. So all of this is the major arc.
Okay, I understand now.
Okay, and it is greater than 180 degrees. So when you think about a circle, if a circle has an angle in it, the piece, let's say this was a pizza. So the piece of the circle or the piece of the pizza that moves with the angle, we call it the related angle. right? I mean, the related arc. So this angle, ACB, well, the minor arc is from A to B, and then the major arc, normally you have another letter out here. So we'll call this point D. We'll call this point E, even though it doesn't have any angles drawn to it, but there's still points on the circle. So to name a minor arc, you only have two letters. Okay? Where does it start and where does it end? So a minor arc has two letters. Where did it start? Where did it end? It started at A, it ended at B. Now, if you see it in a book or printed, it will just have an actual arc over the letters. Okay? Now, a major arc, because it is so large, and it too will start and stop at the same place as the minor arc, but you name a major arc in three letters because the letter in the middle tells you direction. Okay, so let me I'm gonna put this inside here. Minor arc is less than 180 degrees because I want to use this space. All right, so to name a major arc, you use three letters. Okay, so again, you start at the same place as the minor arc, A, but then you have these two points in between. So you can use either of them because now you are telling the reader that you are starting at point A, you are moving through, I'm going to use D, you are moving through point D and you are ending at point B. So the reader knows if they just saw notation and didn't see the actual circle, they would be able to know that the smaller piece, the smaller arc of the circle goes from A to B, and then there is another portion of that circle, the major piece that starts at A, there is a letter D in between, and it still ends at B, and then again, the arc is just wider. Okay? And we're going to get into measures where you'll see this relationship a little better. Okay, when we add numbers. Make sense? A little bit? Possibly? Could be?
Yeah.
All right, cool.
Of course.
Yes.
Yep. So this is the this is the minor arc. And the major arc is purple. Okay. All right. So I'm going to go back to our slide. And oi. Hey, y'all.
What is he looking
Miss
at?
Hicks.
Oh, it's that Michael. Oh, hello, sir. I am so glad you're here. Glad you're here. Glad you're here.
Again.
I am. All right. So let me go back to my share. Boop. All right. So we're going to add some of this stuff that we put up here. I'm going to add it to the slide. All right. So a minor arc. MEASURE. Oh, what did I do? Measure is less than 180. And we are going to then find an example from our diagram that fits the description And we want to say measure is greater than. All right, so now here's where we are. Bam. All right, so we have a couple definitions now. So a minor arc has a measure that is less than 180 degrees. A semicircle has a measure that is equal to 180 degrees. And a major arc has a measure that is greater than 180 degrees. So when you see these things in print, either by notation or by measure, you should be able to kind of, determine which arc goes where. So for us, now that we have this circle, a minor arc, I asked you for an example. So remember, an arc is a portion of the circle between 2 points. I still can't get that on there. Okay. So an arc is the piece of a circle, wait a minute, between 2 points. Can I use that number? All right, so now, somebody give me, oh, come on. Somebody give me an example of a minor arc. I'm gonna blow, wait a minute, somebody's talking to me. Okay. All right, so so I put this I use this circle because we can use the numbers to count, right? So I'm going to give you an example of what I'm talking about. So if we look at the arc from A to B, it's supposed to start at 0 and end at 40. I haven't done too well with matching them up, but that should be at 40. So what we would do is, then it must be 5, 10, 15, 20, 25, 30, 35. So that arc is 40 degrees. Make sense? So an example of a minor arc is the arc from A to B, which equals 40 degrees. Make sense? We just counted. Okay, so can you give another example? Somebody, can you give me another example of a minor arc? And its measure. And again, unfortunately, I can't put the arc symbol over top. I don't have that capability, but if I could, I would. No. Okay. Anybody have an example of a semicircle? You forgot. Anybody wanna anybody have anything to offer to name a semicircle? Now you name a semicircle the same way you name a major arc. You name it in 3 points because remember the point in the middle helps the reader with direction. Nobody? Everybody knows that abbreviation means width, right? The W. The W with the line. No. Nobody. All right, well, let me help y'all out. So a semicircle, you can go up top or you can go down the bottom. Either way. So you could have arc EAC if you went up top. Or you can go down the bottom. this. Um, um, ladies and gentlemen, this really only works if you participate. I just need you all to remember that, okay? Like, I don't know. I don't, I don't, I don't understand. We got at least 6 more weeks of school. So how am I gonna know what you know if you don't talk? Because the only other way I'm gonna know if you know is if I give you a test. And it's not always the best way either. So I am going to all right. So now you have a minor arc from A to B that is 40 degrees. So now in the major arc, we are going to address that. That is the minor arc. So now you are going to do the major arc that matches, or that would be the partner of this minor arc. So the major arc went from the minor arc went from A to B, starting at A, going to the right, stopping at B. So now the major arc will start at A, however, it will go to the left. And you have all of these points in there that you can use as a reference point to let, again, the reader understand that you are starting at point A, you are moving through whatever point you choose. I am probably going to use the point C and ending at point B. And again, if the measure of the minor arc plus the measure of the major arc equals 360 degrees, then we should also be able to figure out, again, the measure of the major arc. And I'm going to leave that one to you. So I'm going to finish our slide. So if we had arc AB, and again, I'm going to leave this for you. I'm going to do them both, so I might as well just copy it. All right, I'm going to have to do something else. Oh, sorry. I am just trying to make sure that it all fits. Okay. So now, again, I said to you all that I am going to use C as my way of letting the reader know, for my major arc, I am starting at A, I am moving through C, and I am ending at B. So if the minor arc was 40 degrees and the major arc and the minor arc together total 360 degrees, then you all will fill in the blank. If we looked at the minor arc AC, then its major arc, I will use D to name the major arc. So we are starting at A, we are moving through D, ending at C. Again, the minor arc was 90 degrees. It will be left to you to find the measure of the major arc. Okay, so again, the minor arc is 40 degrees. The major arc goes to the left, A, all the way around through C, ending at B. It is your task to figure out that measure. Then in the second example of a minor arc, we looked at the arc from A to C, which we found to be 90 degrees. So the major arc, again, starts at A, goes to the left. So through D, ending at C. It is your task, again, to find the measure of the major arc. Okay, and I will put back up here that all right, so I will, for all of you screenshotters, all right, for everybody who takes a screenshot, take a screenshot. Again, the measure of those major arcs, I'm leaving those to you. You have the measure of the minor arcs. We will continue with this when I see you all on Friday. Okay, I am going to stop the recording.